Hi, yeah, my name is Harald Wüst. I'm from Visometry, which is a startup from the Fraunhofer IGD located in Darmstadt. And during my time at the Fraunhofer, we did lots of applied research in the areas of augmented reality. And for augmented reality, the biggest challenge is to estimate the camera position in relation to anything. And we started there with markers and also implemented visual inertial SLAM solutions. But what was mostly interesting for industrial use cases was the referencing in a camera image by the 3D data of any physical object. This is interesting for industrial use cases because we can directly rely on the 3D models, on the 3D data. And so this is what we had like in our first product. So we called this VisionLab SDK, which is like a computer vision system, mostly addressing augmented reality developers who want to create augmented reality applications with any kind of devices. Of course, most people use, like, as you see here, iOS devices or like any kind of mobile systems like smartphones or tablets. And provide any kind of augmented reality systems, as you see here on the bottom video. This is like a marketing use case for showcasing interesting products at trade shows. But this system can also be used for training or maintenance and repair. And yeah, there's a wide range of augmented reality application areas where this technology can be used. Then based on this core system, the computer vision core system, where the main focus is to create like a connection between the 3D model, the physical, like the virtual 3D CAD data, and like the physical object. Based on this, we created like another product. We called this Twin, which is like in relation to like digital twins. A solution for quality engineers who want to put the 3D data in comparison with the real physical world, like with the physical objects. And what we have here is like an example for a certain part, which is like a part from a agricultural machine supplier. And the problem what they are facing is that they get lots of parts from their supplier, and their supplier, they are like smaller welding companies who create like these products, and they are produced like in very low quantities and like in high variations. So this is like often very individual problem. So the need for like a quality system with like very little preparation and learning phase is needed. So if this is like a complicated training phase, then it would not be useful for these small series. So yeah, and so this is like the idea which we want to approach for like these quality engineers. So this is like a powerful software for quality control based like on visual inspection and the augmented reality idea behind this visual inspection. So we would like to fulfill the promise for like the quality engineers that they can do like a very quick and easy inspection process with a mobile lightweight solution. So this is like a very typical use case. The quality engineer is like out on the parking lot where a supplier brings some parts, and he's now interested in detecting the differences between the virtual 3D data, like the 3D CAD data, which has been used to define the part. And now we see the quality engineer to directly identify the differences between the virtual and the physical models. So. And the idea is to get like a very quick view of like the virtual model in comparison to the physical object, like if all holes are correctly there, or if like bolts or other parts are welded at the correct position. And one option is also to create like this documentation based on this inspection process. So the documentation can also be created like within the whole application. So it's very easy and like fast forward to create like the results of this quality inspection process. So in relation to typical other approaches, like there's this manual inspection when there's like very low quantities and it's not worth to get like a very complicated inspection tool. Many people still do like a manual inspection based with like manual tools, which is of course time consuming and not very precise. Like on the other side, there are like these high precision measurement tools like the Faro device or like GOM devices, which can do like very high precision measuring, but these cost like about like 80K or more for like just getting such a device. And with our mobile solution, with the Twin, we are kind of in between this spot that we do like a lightweight tablet-based solution. It's just like an iPad you need, so it's like a consumer cheap hardware. And like with our software, we can have like a mobile system which can be used anywhere. So you don't have to carry like big, complicated structures onto some measurement device. For example, here there's some other use cases where like bigger welded parts, and our computer vision system can do like this precise alignment based on the 3D CAD data, and the 3D CAD data is also superimposed or visualized onto these camera images, and it's easily detectable that we see that this pipe has some errors at the lower end, or it's also detectable that on the other side here we see a couple of spots where like some flanges are positioned, and so we can see like on a millimeter accuracy that these parts are all at the correct position within the overall physical part. There are different functionality areas. So one possibility is to use this during the assembly process. So while certain products are assembled, and to use the tablet solution to do like intermediate validations if the assembly has been correctly done, and so that during the further assembly process there won't be any following errors. So this is like also typical for these geometric validations for incoming goods, like the OEM manufacturer. He uses the software for checking the incoming goods, and the supplier can check this as an end-of-line control if like all these parts have been produced correctly. Then for tool making, this can be used if like a tool is assembled or set up, and you always have like a very quick comparison between like the virtual 3D data and like the physical setup you want to create. Then you don't need like other techniques to do like a quick comparison between virtual and physical. And also like measurement validation. If you have other machines where you collect like measurements, it's a visualization technology where you can visualize the results like physically on the real model. The software, like our core computer vision system, which we also sell as an SDK, this runs like on any device. So this is also like for Android and iOS and Windows Native. We also provide it for like the Windows Universal platform for the HoloLens mostly. And for the Twin system, we first addressed like iOS devices because like for quality inspection, tablets are like a very neat device compared to like goggles or glasses. Glasses, of course, are good if you want to work hands-free, but for the inspection process, it's always interesting to interact with the application itself, and therefore tablets, we always advise like our customers, tablets are a much nicer augmented reality experience than like a HoloLens, glasses, or any other augmented reality devices. And so the other part is like a desktop software where the use cases can be authored and the 3D CAD data can be imported, and they are transferred to the iOS device. And the iOS device is then like the mobile solution, which can be carried like anywhere on the shop floor. So the biggest benefit of this mobile solution is that it's that it's like flexible in the usage, so it can be carried like to any point in the production process. So it doesn't need to be installed at a very certain specific point, but can be used like anywhere on the shop floor or in the assembly halls. And it's like very easy to set up because all you need is like the 3D data. So the 3D model of this object, and there's no preparation or no pre-processing step. So because we don't use any AI system which needs any learning, but we only rely on the 3D geometric data for the referencing. We don't need any learning phase. So it's a very quick method to get the system running. So that's a quick overview of the workflow. So take the 3D data, then process it on the desktop software, transfer it on the iOS device, carry out the inspection process on the iOS device, and get the inspection report back and use the inspection report for the whole quality management system. So at the beginning, as I just mentioned, we have like the setup process. Here we have like a CAD optimization framework where we take the 3D CAD data and import this, do like some simplification with the CAD data so that it is also possible to take like even gigabyte big 3D data. So this will be reduced in a format so that only visible stuff will be exported on the iOS device. Then on the iOS device, the inspection task can be carried out, and then we get like as a result the inspection report. So here we have like an example of a really huge project. So this would be like kind of complicated, putting this into like an inspection process, like a faro arm, because this is just like a very heavy, bulky object. And here the quality engineer can just go out somewhere on the parking lot and also inspect like these really big objects and check like if all parts are correctly welded and assembled. And so here it's like detected that these holes have been left out, and the whole inspection process can be carried out like within a couple of minutes, just right on the parking lot. Here's another example of a very bulky object. And so here again, this would be impossible to put this on a measurement table or like any other a measurement device. And with a mobile solution like an iPad, we have like a very simple tool to just do this comparison between like virtual object and the physical built object in a couple of minutes. And here it is observable that some parts of this object have not been like there's this bar at the side which is just like a bit too short, and this can be quickly detected then with our software. And at the end we get the quality report which documents like all the differences. This is like just like a quick overview of like all these features which we provide. So at the on the first side, we have as a core feature this model-based tracking that we can always rely or like have a very direct connection between like the camera image and the 3D CAD model. And this is like our core functionality. But then we can also define the inspection process so that we have certain viewpoints, and the viewpoints can be used as a step-by-step instruction to guide the quality engineer to look at certain positions. Then some other feature is like a lens tool or like a code scanner to identify certain parts within the inspection process. Here, this is an example of this lens feature. Here we can just put the virtual model in overlay with our system, and the lens feature can also be used and also connected to a certain 3D position, so that this feature can be evaluated like very precisely. And as I mentioned, we get like an accuracy like up to like a millimeter, and then it's like possible to detect if there are some certain holes within this welding constructor at the correct position. Then here is like another object. So this is like some automotive part, and here we can also use this feature to compare like virtual and physical objects just next to each other, and based on that, it's also easily, quickly possible to do like this comparison between virtual and physical objects. Then here's like another example of one of our customers. So yeah, this is like one of our customers, Krone. They build like agricultural machines. They are interesting for this application because they also build like they are special vehicles built like in a small quantity, but with a high variation. So there's no, like, these machines are very individual all by themselves, and so they it's like hard for them to create like an automated quality inspection process. Here, this is like a challenge they provided for us to detect like a couple of errors. And so they knew that there were some of these bolts like wrongly positioned, and like so this was easy to detect with our software that these lock barrels were positioned wrongly. But we could also show in this scenario that we could detect way more errors than they provided for us to detect as a proof of concept. So that, for example, these camera adapters were wrongly positioned, and so yeah, they quite were amazed that like the system could be used and to detect like way more errors than they were expected, that they already knew. And yeah, so since they've been like our reference customer with our application, they use like our software in a daily use with a couple of quality engineers, and used to check the supplier parts which they get delivered from their suppliers. Here we see another typical use case of the whole workflow of the inspection system. So here the quality engineers can also use the software to annotate like errors, or like to go through a step-by-step inspection process and tell, okay, these parts are like correct, like these holes are like at the correct position, and then annotate like these parts which will end up in the quality report. And here we see like an example of a hole which has been positioned wrongly in the virtual model, or which has been wrongly built in the physical model. So it's easily detectable, these differences between the physical and virtual worlds, and can be documented also like in an easy process. And at the end, we have like this quality report with a couple of screenshots where we can process those documents further in the quality documentation of these parts. And since it is such a quick process, we can also do this inspection with lots of parts. So we don't have to only pick a couple of items, but we can also make these inspections on a much wider range of parts, because the inspection process can be carried out quite quickly. Like, here's another use case where it's also possible regarding towards these manufacturing processes, or like where like the system can also be used to not only check for quality errors, but also to guide people in the manufacturing process. So here the virtual parts which are not assembled yet, they are visualized with in the camera view, and this can be like used like as instructions for like certain maintenance or assembly tasks of these products. And then, yeah, so like as I mentioned, there's this possibility to create like a step-by-step instruction, and these instructions are all prepared within the desktop software. And while during the runtime, these different parts can also be dynamically visualized for different purposes. Also interesting, for example, for the visualization of different variants. So in the area of prototyping, if you build like a prototype and want to check if all parts fit to the physical object. And so, yeah, like these are these 3 blocks, the Twin Studio, like the desktop software to set up the inspection tasks. The Twin View is like the iPad app to carry out the inspection with a mobile system. And at the end, we have this documentation process where we get like the quality document, which documents like all the different issues of the object or the quality inspection process. What's okay or what's not okay, where like improvements, and what if there are any other things. Like here, we see like another feature which we provide. So we have the function or like the possibility to track the object itself, but we can also track the object, or like the body of an object and like another object. So different objects in relation to each other. And what we just saw here, we had like the car, like the door of this car as a body, and then the window lifter as an object we want to test. And our software can be used to track these objects individually of each other. And so it's also possible to track the transformation between these objects. Like here's another example. When the part is missing, it's like visualized in red. And our system detects that at this position, the object is not correctly placed. So here we track like the body and the part itself. And then when the part is like correctly, like at the correct position, the system detects that this part is like at the correct position, and is also be detected automatically that the placement of this part is like well done. So yeah, this is like an overview of like our twin solution. Like as I mentioned, we provide this as a solution addressing quality engineers who want to carry out like a inspection process, but we also provide this as a technical building block for any kind of augmented reality applications. Here's another example for this tool table assembly, that our system can also track the table and this tool, and when the tool is placed correctly, the system also automatically detects that this part is like at the correct position. Yeah, if you want to see like our technology in real, we have like a booth in the other hall, and of course you're welcome to visit us there at the booth, and we can also show you more of our technology. So yeah, that's it so far. Like if you're interested in the twin system or the VisionLib SDK as a technical building block for your own application, like for example, we have like also robot customers like ABB who use this technology within their robot control. So camera on the robot arm detects the object, and the object can be moved during the manufacturing process, and our software does the job to always identify the correct location of this object. Okay, so yeah, thank you very much for your interest, and yeah, I'm happy to answer any questions.